Hi everyone, welcome. Here are the big takeaways from that last chapter 10 on simple experiments and the current chapter 12 topic of experiments with more than one independent variable. The second of two lectures about experimental design, the underlying logic of an experiment, and the statistics associated with specific experimental designs. So, big takeaway from this chapter 12, experiments with more than one independent variable. First big takeaway, there are three experimental designs available for your use in the experiment that you're designing for your research proposal for this class. There exists a relatively small number of choices that researchers are likely to use in designing any experiment. Let's talk about them. First, the one independent variable two-group design is as simple as it sounds. One independent variable that compares two groups, often an experimental group and a control group, but not always. Most students in this class already have designed a one independent variable two-group design, and so here we are only giving a formal name to your design. That's all. Second type of design is called the one independent variable multiple group design, which is a simple extension of that basic one independent variable two group design. Multiple group simply means more than two. That's all being compared. Third, become familiar with this new two independent variable factorial design, because it is the most common design used in experimental psychological research. Psychologists have discovered that examining the effects of multiple two independent variables at the same time within one experiment more closely resembles the real world. That makes a lot of sense. And there are probably fewer situations where our behavior is truly affected by only a single factor at a time. A great strength of this two independent variable factorial design is that it allows us to examine the effects of combinations of independent variables at the same time, and those are called interactions. Studying two independent variables at once allows psychologists to examine what we call a synergistic process, meaning that when we combine two or more variables, two or more conditions, and the resulting effects on the dependent variable are actually greater or different than what is possible with each individual independent variable. These are just a couple of reasons why the two independent variable factorial design is the most common design in experimental psychological research. Second big takeaway from this chapter is about this relationship between experimental design and certain statistical tests. For your research proposal, you should know that your chosen experimental design dictates what the particular statistical test that you will use to analyze your resulting data. Experimental design and statistical analyses are intimately linked with each other. First, if you chose the experimental design called the one independent variable two-group design, then a t-test statistic is appropriate for you because you're comparing two levels of your variable under study. Usually the resulting scores from the experimental group versus the control group. A t-test is an inferential statistical test used to evaluate the difference between the means of two groups. That is its definition. You're comparing the average scores between being measured in your dependent variable, specifically comparing the score associated with the experimental group against the score associated with your control group. Second, if you chose the experimental design called the one independent variable multiple group design, then know that a one-way ANOVA is the appropriate statistical test for you because you're comparing the difference between the means of multiple groups of one variable. That is the definition of the one-way ANOVA. Third, if in your professional future you choose the experimental design called the two independent variable factorial design, then a two-way ANOVA, also known as a factorial ANOVA, is the appropriate statistical test for you because you're comparing the difference between the means of multiple groups of two independent variables. And this very powerful design produces results showing main effects and interaction effects, as described in your textbook. It's really interesting. And that's why it's the most popular choice in experimental psychological research. In the back of your lecture notes for this chapter is a really nice table summarizing these automatic choices. If it's this design, it's this statistic. This design, this statistic. It's automatic. The page is titled Experimental Design and Associated Statistics shows how each chosen design dictates the appropriate statistical test. So that choice is going to be really easy for you. The test to analyze its resulting data. Finally, takeaway number 3 is a reminder that as we leave these chapters about the importance of extraneous variables. These chapters put special emphasis upon extraneous variables, defined as any variable that poses a threat to the validity of the proposed cause and effect relationship, because it compromises the interpretation of research findings. That is, the experimental extraneous variable compromises the internal validity of the proposed cause and effect relationship and makes us doubt that it's believable. Extraneous variables, remember, are external influences, external to our interests. So the third takeaway is simply, you'll see these concepts again, this idea of the extraneous variable. You'll see these concepts again in the idea of control processes in the next couple of lectures. We want to control, that means minimize the influence of extraneous variables as much as possible by making design decisions that one by one logically eliminate the possible influence of known extraneous variables. And I'll show you how to do this. Recall that an experiment is a somewhat artificial attempt to isolate and examine a unique relationship between your chosen independent variable and your chosen dependent variable. And in real life, extraneous variables are always present. That's what makes an experiment kind of artificial. We'll talk in the next couple of chapters about how to make design decisions that logically control for extraneous variables, eliminate the influence of extraneous variables. One by one, we eliminate them as possible alternative explanations for any observed changes in our research results. So in summary, the big takeaways from this chapter 12 topic on experiments with more than one independent variable are these. Number 1, know that there are only 3 experimental designs available for use in the experiment you are designing for your research proposal. 1 independent variable 2-group design, 1 independent variable multiple group design, and the 2 independent variable factorial design. Second big takeaway, for your research proposal, you should know that your chosen experimental design determines the particular statistical test that you'll use to analyze your resulting data. For example, if you're using the 1 independent variable 2-group design, then a t-test statistic is appropriate for you. And the third takeaway from this chapter, these chapters' emphasis upon extraneous variables should remind us that we're going to see this again as we study the idea of control processes in the next couple of lectures. We'll talk in the next couple of chapters about how to make design decisions that logically control for extraneous variables and one by one eliminate them as a possible alternative explanation for any outcomes observed in our research results. Those are the big takeaways, guys, from this chapter 12 topic of experiments with more than one independent variable. Thank you, everyone.